All right, 6-4. Today we are doing arithmetic series. Notice the word says series and not sequence. So what is a series is? A series is the indicated sum of the terms of an arithmetic sequence. Fancy 4, you're going to add up all the terms of the given arithmetic sequence. That's why it says indicated sum. It may indicate to you to add up the first 10 terms. It may indicate you to add up the first 100 terms. All right, so here we are. We have Gauss's famous problem. Add up the first 100 numbers. Just to review, a sub 1 means we're talking about the first term of this arithmetic sequence. A sub 2 means we're talking about the second term of the arithmetic sequence. And since this is an easy sequence, it's always the corresponding number. So in the fourth spot is the number 4. And mind you, that doesn't always happen. All right, so if we remember what Gauss said about adding it up, we're going to look at this formula a little different way. Right here, a sub 1 is the first term. This is the second term. We get it by taking the first term and adding on the constant, right? The second term here we know is a constant of 1. So 1 plus 1 got me my second term of 2. Get it? Take the first term and add on one common difference. This represents the third term. And we get the third term by taking the first term and adding on two common differences. The common difference is 1, so 1 plus 1 plus 1 would get me 3. And it goes so forth and so forth. So to get the fourth term, we take the first term and add on 3 common differences. And dot 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 means this goes on forever and ever until the final term. The final term is found by taking the first term and adding on n minus 1 common differences. So if we look at the number 100 here, we know 100 is in the a sub 100 spot. And how did we get that number 100? We took the first term, which was 1, and we added on, well, 100 minus 1 is 99, so we added on 99 common differences to get the term 100. All right, so why are we doing that? Because we're going to see how Gauss developed a couple of formulas. So here we have any arithmetic sequence written in algebraic form. First term plus a common difference, first term plus 2 common differences, first term plus 3 common differences. So what did Gauss say to do to make his shortcut in how to add up any series of numbers? He said, add the first and last terms together. And there's our picture of Gauss right down there. So the first term is a sub 1, and the last term is a sub 1 plus n minus 1 times d. So here's my first term, and here's my last term. Now what did we get when we clean that up? Well, a sub 1 plus a sub 1 gives me 2 a sub 1s, and then I still have the n minus 1 times d. And then Gauss said we're going to multiply by how many pairs of numbers we had. And he found out pairs of numbers by taking n and dividing it by 2. For example, if you had 5 numbers to add up, 5 divided by 2 means I have 2.5 pairs. First and last makes a pair, second and second to last make a pair, and then the guy in the middle, so sad to be him, he does not have anybody to pair up with. 2.5 pairs times what I got when I added the first and the last term together. So you have 2 formulas that you have to remember that will help you find the sum of an arithmetic sequence. You can use Gauss's straight up formula, the sum of any arithmetic sequence of n, add the first term and the last term and multiply by the pairs of numbers. Or you can use his algebraic one, which is the same thing, to find the sum of any arithmetic sequence with n terms. We multiply by the pair of numbers, and then this also represents the first and last term written in algebraic form. So, which one are you going to use? It all depends on the question. Let's look at this example. Write the sum of the first 15 terms of the arithmetic sequence. 1 plus 4 plus 7 plus ... Now the indicated sum is they want me to do the first 15 terms. And I know some of you are going to take the baby way and you're going to go 1, 4, 7, 10, 13, 16. You're going to write out the first 15 numbers, then whip out your calculator and try and add them all up. Ridiculously long. So let's try and use Gauss's formulas. Well, which one are we going to use? Well, let's start with the easy one. The easy one says I have to know to find the sum of this arithmetic sequence for the first 15 terms. N is 15. I'll take my 15 terms and divide them by 2 to figure out how many pairs I have. And then I have to take the first term, which is 1, and add on the... Wait, I don't know what my last term is. So that gives me 2 unknowns. I can't use this formula. I will have to use the second formula. To find the sum of the first 15 terms, I take the pairs, I double the first term, okay, so 2 times 1 is 2, and I add on n minus 1, well n is 15, so I'm adding on 14 differences. Alright, what's a difference? What's the difference between 1 and 4? 3. What's the difference between 4 and 7? 3. Okay, so my differences are 3. Oh, great, I have no unknowns. I can figure this out. 14 times 3 is 42, plus 2 more is 44. And I'm going to multiply that by 15 halves, or cross cancel. So 15 times 22 is 330. So the sum of the first 15 terms is 330. All right, example 2. The sum of the first and last term of an arithmetic sequence is 80. All right, so the sum of the first and last term gets me 80. The sum of all the terms is 1200. So I know the sum, and I don't know how many terms I added up, but I do know the sum of a sub n is 1200. How many terms are there in the sequence? So they're asking me to figure out what n is. Once again, which formula am I going to use? Well, let's try the easy one first. This one. Let me clone that and bring it down over here. This says, do I know what the sum of a sub n is? Yes, I do. It's 1200. I know all my terms add up to 1200. Do I know what n is? No. Do I know what my first term is? No. Do I know what my last term is? No. Oh, but wait a second. My first and last term, when I add them together, gets me 80. And isn't that what this is asking? Take my first term, my last term, add them together, and I get 80. Excellent. Now I can solve this. Cross cancel to get 40. 1200 equals 40n. So n equals 30. There must have been 30 terms in this sequence. That's it. Done.